Chapter 5 Radio Wave Propagation. When a radio wave leaves a vertical antenna, the field pattern wave resembles with a huge donut light with the ground over the antenna. The whole of the stem of the part of the wave moves outward, contact with the ground with the form of the ground wave. The result of the wave moves upward and outward to the form of the sky wave. Ground and sky portion of the radio wave are responsible for two different methods of carrying messages transmitted with the receiver. The ground wave uses both short-range communications, high frequency, low power, for long-range communications, low frequency, with high power, daytime reception with more nearby commercial stations is carried with a ground wave. Sky wave is used in long range, high frequency daylight communications. Night sky wave provides a means of long range contact, somewhat lower frequencies, and acts somewhat differently from the ground wave. Some of the energy with the sky wave is refracted, bent with the ionosphere, so it comes back toward the Earth. The receivers are located in the vicinity of the returning sky wave, with the receiver throwing signals, even though they're several hundred miles beyond the range of the ground wave. Ground wave completely concerned and made up of three parts: surface wave, space wave of the Earth, reflected wave of the surface wave travel to the Earth's surface, space wave travel to space immediately above the Earth's surface. The Earth reflected wave reflected with the ground before the reach of the receiver. The sensitive wave follows the path of a different length of the components, or may arrive in and out of phase with each other. Thus, the distance of the transmitter change of the components may be additive, they may be cancelled with none of the components wave to the effect with the reflecting layer of the atmosphere high above the surface of the Earth, what we call the ionosphere. Space wave of the ground becomes more important frequency increase with the transmitter, with the receiver. The antenna has height is increased with the transmitting receiver. The antenna both the closed on the ground and the space wave components may cancel with the true because of the ground reflective with the component is shifted 180 degrees in favor of the reflection, same magnitude with a different component travel the path with approximately same length with a direct component. With the surface wave with the ground wave that is responsible for the most daytime broadcast receptions. Ionosphere of the found with a rare field atmosphere approximately 40 to 350 miles above the Earth. The difference from lower atmosphere contained with a much higher the number of positive and negative ions. Negative ions will leave with a free electron. The ions are produced with the ultraviolet particle radiations from the sun. With the rotation of the Earth of the axis of the annual course of the Earth of the sun, with the development of the sunspots, all of the effect of the number of ions present in the ionosphere. Then these turn in effect with the quality of the distance radio communications. Altitude of 350 miles with the particle with the air is to spare permit large scale information below. With the 40 miles, only a few ions present will become because of the rate of the recombination is too high. The sun's ultraviolet radiations have absorbed them in the passage through the upper layer of the ionosphere, with the result of the below of the elevation of 40 miles with the too few icons materially affect with skywave communication. Question in this section is pertaining with the radio wave characteristics and propagation. This includes the definition of various terms associated with the radio wave as a natural phenomena that affect with the transmission through the space of one station to another. Basic data such as speed, radio waves, length of the radio wave, with the frequency, how daylight affect with the wave propagation. Covered the last question section. Sample question prepared with the Federal Communication Commission. What are ground waves and sky waves? Primarily with the two types of the transmitted electronic wave of the ground wave and the sky wave. The ground waves of those who travel near the surface of the Earth. The waves are greatly affected with the conductivity of the Earth and obstructions such as mountains, buildings of the surface of the ground wave. Transmission is usually primary for the local communication. Ground wave composed of a three-wave space with the tropospheric wave and the Earth reflected wave and the surface wave. The space wave is called the direct wave of the sky wave, the electromagnetic wave, which is propagated at such an angle that travels with the atmosphere, strike with the upper layer of the atmosphere called the ionosphere, as it is refracted back towards the Earth. Skywave transmission with a long-distance transmission. 5.2. What are surface waves? Surface waves are with the ground wave that travel to contact with the Earth surface with the conductivity of the Earth surface. Some of the energy surface wave will be absorbed by the ground since the Earth surface is most location excellently since the Earth surface is most location excellent conductor on the passing electromagnetic energy will cause eddy currents to flow on the ground. The eddy currents dissipate power. They classified as loss. Eddy current losses are greatest of the surface where waves polarize horizontally, and at least when the surface waves are vertical. The surface waves rate with a diminish shown in Figure 5.1. Shows the antenna surface wave Earth angle of tilt. Low frequency transmission, equal radiation in all directions. West coast, strong, very weak, negligible, strong, very weak, negligible. Pacific Ocean. Since the electrical property of the Earth over the long with the surface of the wave with the travel the relative of the kinds with a single string with a given notation with a given point with a fairly constant with a whole true with nearly all localities except that have the distancing rainy or dry station chain with the amount of moisture called with the conductivity of soil chain with the conductivity high with the absorption over the low and transmission surface of the wave can be achieved over the considerable distance. Conductivity low with the absorption transmitted energy will be high with the distance. Transmission realized to you with the surface of the wave will be short with a different type of the trains have the various effect of the absorbers and radio frequencies and surface of the wave. If the surface of the wave is transmitted over the water, especially salt water, transmitting the distance of the surface of the wave greatly increases the illustrated in Figure 5. 2. What is a direct free space wave? The direct and Earth-reflected waves shown in Figure 5.3 are also called free space wave of the trophospheric waves. The name trophospheric wave is given of the medium from which the space travels the troposphere portion of the atmosphere directly above the Earth's surface. As shown on the diagram of the direct wave of the component space wave of the travels in almost a straight line with the transmitting antenna with the receiving antenna. The type of the transmission strictly lead with the direct wave is known as the line of sight of the transmission. Line of sight transmission means both the transmitting and receiving antennas optical visible to one another. The direct wave travels almost a straight line, slightly bent with a trophospheric refraction. This cover the direct wave is bent back toward the Earth and extend the transmission beyond the optical horizon. Refraction electromagnetic energy occurs with a manner similar to the refraction of light. Refraction electromagnetic and light energy is called the energy passive of one density of the medium to another. Defining skipping and skip distance. Sky waves are those with the radiate with the transmitting antenna. The direction produces a large angle over the reference of the Earth of the sky wave, the ability to strike with the ionosphere of the refractive of the ground and strike with the ground with the reflected back for the wave of the ionosphere and so forth. The refracting and reflecting action ionosphere and the ground is called skipping, and the illustration skipping effect shown in Figure 5.4. Transmitted wave leaves the antenna at point A is refractive of the ionosphere at point B, reflected back from the ground. Shows those transferring of the direct wave of the reflective wave in the Earth and receiver. At point C with the refracted ionosphere of the point D with the arrive of the receiving antenna of the E with the at point A and C with the from the C and E with the indicate with the distance known with the skip the distance region with the end of the over the surface of the wave with the point C is known as the skipped and quiet zone. Because of the receiver to located with these region with the would receive with none with the transmitted with the wave with the possible have with the propagated wave leaving the antenna with the greater angle shown in Figure 5.4. Conversely, conceivably reflected into the region change with the happening is wrong with because of the angle of the sky wave to strike with the ionosphere critical. This is another quiet zone with the points between C and E. When the ionosphere of the as for the electronic radiation concerned, there are only three layers of the atmosphere of the triosphere of the stratosphere and the ionosphere of the triosphere that extends from the surface of the Earth to the altitude of approximately 6.5 miles. The next layer of the triosphere extends up or limited the triosphere approximately elevation of 23 miles, and from the upper part of the stratosphere with a distance approximately 250 miles region known as the ionosphere. The ionosphere is appropriately tilted because it is composed primarily ionized particles with density up to the extremity. The ionized sphere is very low, but becomes progressively higher at the extent of the downward toward the Earth, and the upper limit of the ionosphere of the subject of the sphere of the Earth. Radiation from the sun with the radiation from the sun with the form of the photon with gamma rays of the higher energy particles. Even though the density of the gas of the upper ionosphere is small, the radiation particles is higher with such with a high energy with the cover the wide scale with the ionization gas items of their present with the ionization extends down with the ionosphere diminishing in intensity, therefore, with the highest degree ionization curve of the upper proximity ionosphere with the lowest degree with the curve of the lower portion of the ionosphere. 5.6 is defined with the F2 layer of the ionosphere with the composed of the three layers of the designated with the respectively lowest high developed level D and E and F. F is for the daylight hours of the two layers designated F1 lower layer, F2 higher layer. Present with the absence of the layers D and E and F over the ionosphere with the height above the Earth vary with the position over the sun. So the transmitter surface wave, the quiet zone and the quiet zone receiver, E, A, B, A, and C, skip distance, and D, B, and D. If layers exist with 90 to 240 miles, the ionization level of the two layers of the quite high varies rarely depending on the degree of the notion and new of the portion of the atmosphere close to the sun with the degree of the ionization is maximum. So the atmosphere is rarefied and heights can recombination ions occur slowly of the sun that therefore the fairly constant ionized layer of the present and all time of the F layers are responsible for the high frequency long distance transmissions. Relative to the distribution ionosphere layers are shown on the Figure 5.5 of the distance with the disappearance of the letter D and E with the later at night singles normally reflected layer with the refracted as much of the higher layer will result in greater distance. Skip distances at night is shown in Figure F6. 7. To define a sunspot cycle. Layers on the ionosphere undergo the considerable variation of attitude of the density of the thickness due to primary varying degrees of solar activity. The Figure F2 layer undergo the greatest variation due to solar disturbance of sunspot activity. There is great concentration of solar radiation in Earth's atmosphere during the peak of sunspot activity, which occurs every 11 years cycle. During the period of maximum sunspot activity, the F layer is more dense and occurs with a higher altitude shown in Figure F7, and with the Figure F7 conditions shown with the transmitted wave fronts A and B. Radiation from the sun with a night of the day F2 layer with the 180 miles, 100 miles, the F1 layer, 30 to 55 miles out with 107 to 200 miles night and day ionosphere, having a different angle of the radiation during the period of the minimum spot activity lower altitude of the F layer returns to the sky with a wave of the dotted lines of points that are relatively close for the transmitter compared with the higher altitude of the F layer occurring during maximum sunspot activity. Consequently, skip distance is effective with the degree of the solar distance. What is wavelength? Wavelength is the distance AC alternating current signal wave which will travel during one complete cycle with a wavelength show with a frequency with a 300 megahertz signal with a wavelength of 1 meter, while 1 megahertz signal has a wavelength of 300 meters, which is more meant horizontal vertical polarization radio wave of a wave. What is meant by horizontal and vertical polarization of a radio wave? Radiation energy of an omnidirectional antenna is the form of the expanding sphere of the special section of the sphere is called the wavefront, perpendicular with the direction of travel of the energy. All the energy shifted in the phase. Usually all of the points wavefront are equal in distance from the antenna. Further from the antenna, less spherical, the wave of the period of the considerable distance away from the considerable the plane surface at the right angle with the direction of propagation. Radiation field is made up of the magnetic electrical line force with always with the right angles to each other. The direction of the polarization electronic magnetic field is considered to be direction electronic vector of the electrical lines of force. Shows the F2 E layer vanishes at night, day signal, nighttime signals, 6 mile skip lower layer, increased distance, lower angle radiation, 6 mile skip distance, upper layer 100. Horizontal wave is said to be horizontally polarized. If the electrical lines are vertical, the wave is said to be vertically polarized. Electrical field is parallel with the axis of the antenna dipole with the reference for the antenna of the plane and polarization. Horizontal place antenna figure 5A produces horizontally polarized wave. The vertical place antenna produces vertically polarized wave with the maximum absorption of energy of the electromagnetic field and necessary with the receiving dipole located plane. Polarization plate for the conductor right at angle with the magnitude. Magnet line of force moving the antenna with a parallel with electrical lines. General polarization wave that do not change the short distance through the transmitter receiver. The antenna orientated, especially short distance, separate them. Over long distance, polarization tend to change. The change is usually small with a low frequency, high frequency, quiet, marked. Alright, shows the horizontal antenna wavefront, vertical antenna magnet lines wavefront, and the Earth. So, F10. What is the speed What is the speed of radio wave? Radio waves propagate free space at 300 million meters per second with approximately 186,000 miles per second. Speed of light and air speed is very slightly less, significantly less than transmission lines, while velocity with a single propagation different with a different material with what effect, if any, would have with the wavelength of the frequency. Velocity with a propagation different from the medium with a propagation effect with the result of the chain with the electrical length of the wire with the type of the RG80U coaxial cable stream of the transmission line with using only VHF transmitter receiver. The velocity factor for the cable is approximately 66%. Thus, for the physical wavelength of the section of the cable is about 66% of the electrical length with equivalent piece of bare wire hanging in a free space. 66% of the length of the transmitted wave in the free space. The free space of the radio wave propagated with the speed of light, or 300 million meters per second, with the velocity of the very slightly less of the transmission line, and with the velocity propagation can be significantly less and most taken into account with the calculating physical length. Radio frequency carrying conductors most half-wave with antennas with a velocity of 95%, of which makes physical length with such an antenna less half of the length of the actual wave in space. Whereas the formula determining wavelength frequency is known. Wavelength length over the wavelength length of the wave is field emitted by the radio transmitter signal since the radio signal will travel the speed of light with the wavelength is calculated by the dividing the number of waves passing 1 second into the speed of light in units per second as an equation as the wavelength is equal to the speed of light over the frequency of the wavelength, generally expressed in meters through, but it can be expressed in centimeters, inches, feet, yards, or miles. Wavelength in meters. Speed of light in meters per second must be used in formulas, and speed of light is 300 million meters per second, at least close enough to see what the number can be calculated. Methods greatly simplified. For example, 300 million frequency hertz of 300,000 frequency in kilohertz, 300 for the frequency of megahertz. In other words, you can simply problem for the expedited remove the zeros of 300 million according to Hertz multiplier. If we multiply one complete cycle with a radio wave with 1 microsecond with 1 millionth of a second wave with the frequency wavelength, and with 1 millionth such a cycle with a propagated 1 second per of the frequency of 1 megahertz megahertz of the wavelength and calculated divided with the velocity radio frequency of the frequency. The frequency is equal to the speed of light over the frequency of the speed of light at 300 million meters per second. The dropping millions both of speed frequency equation of the frequency of 300 over 1 or 300 less to the wavelength of 1 megahertz is single of 300 meters. Would it affect the ionosphere of the sky wave? Ionospheres have the characteristics some of the waves penetrate with the pass of the entirely through with the speed of the inevitable return of the wave with the penetrate with the bend of the generally ionosphere of the active with the conductive absorb the energy of the varying amounts of the radio wave of the ionosphere also with the radio mirror with the reflect with the bends of the sky wave back to the earth illustrated in figure 5.9. Here is the ionosphere that does of the sky wave of the water does not to beam a light. The ionosphere of the return radio wave of the earth depends on the ion density frequency of the transmission angle of the radiation of the reactive power of the ionosphere increase the density with the degree of ionization. Green ionization, when the greater in summer than the winter, is also greater during the peak of the night. Abnormally high density will occur during the times of peak sunspots. So, ionosphere of the Earth. 5:15. What is the effect of daylight wave propagation? Increased ionization during the day with a responsible several important changes of the skywave transmission called for the skywave the return of the either near prior transmission extra ionization increase the absorption energy of the sky wave travel to sufficient detail addition to the ionosphere of the lose of the energy with light loses all its energy presence of F1 and E layers with the F2 layer most make long-range high-frequency communications possible provided the correct frequencies are used. Absorption usually reduces effective daylight communication range, low frequency, medium frequency transmitters for the wave ranges. High degree ionization of the F2 layer during the day will enable the refraction of high frequencies which are not generally absorbed. The important effect of the transmission on a high-frequency board figure 10 show with the frequent F2 layer completes. The F10 show the F2 layer on long ranges of communication transmitter and Earth. F1, F2, F1, and E layer reflection returns transmission of these frequencies of the Earth by making possible long range high frequency communication during daylight hours. The waves of the partially been going through the E layer, the F1 layer, not return to the Earth. The F2 layer, complete with the refraction of the VHF waves, pass directly through the ionosphere of the amateur band used to communicate with another station that depends on the condition of the ionosphere of the distance between the stations. F16, how did the change of the condition of the ionosphere of the sunrise, sunset, effect of the radio signal, how will the ionosphere storm, the effect of the radio signal, change condition, ionosphere of the shortly becomes sunrise, shortly after sunset with the complete blackouts of the certain frequency, high frequency signals pass through the ionosphere of the lower frequency signal that absorbed it. Ionosphere storms of the turbulent condition of the ionosphere they often call the radio communication become erratic. Some of the frequencies will complete blacked out with the other may be reinforced. Some of these storms are developed in a few minutes, but the others the times recover as much as several hours to develop, and the storm might be at least several days. 5:17. How do night and day transmission differ due to the change of the ionosphere of the skywave chamber between the night and day with the ground wave that remains constant with the height of the rays of the sun ionized with the atmosphere during the daylight hours. Night and approach of the ionized particle will become the thinner with the thinized ionized layer refracts the wave back to the earth over the wider arc than does the thicker daytime layer. Radio waves 100 megahertz of the refracted but appear with a pass through with the ionosphere of the frequency with maybe U with the primary ground wave transmission. Radio waves of 30 megahertz to 100 megahertz are not refracted back to the earth during the night, although refraction sometimes occurs during the day, but especially toward the lower end of the spectrum and the frequency most often ground wave transmission. Radio waves of 10 megahertz to 30 megahertz must reach for the long distance daytime communication distance up to 10,000 miles have been reached. Ordinarily, contacts expected with between 500 and 5,000 miles rarely at night with the frequencies pass through the ionosphere that do not return to the earth. Radio waves between 3 megahertz and 10 megahertz are usually daytime communications up to 500 miles, excellent with the nighttime communication 200 to 500 miles, medium frequency signals between 300 kilohertz and 3 megahertz. Used daytime communications have several hundred miles, and frequencies can be used within the night for up to several thousand miles. For frequency of 3 megahertz, a little difference between the day and night signal. A stronger signal appears at night. Radiation field contains answer B, an electromagnetic component. Chapter 6, Amateur Radio Operating Procedure.